3, 2, 1. Thanks. So, for this example, we go through the same process. Now the iPads are down. Sam, for example, as that was pretty explicitly stated. I know that you're checking your homework and doing the right thing. I'm not at all cranky at you, just need you paying attention. So, for that, there's nothing for you there, mate. For question 1C, it's the same process. Okay, we're going to identify we've got a right angle triangle. We want to know something about the right angle triangle that we don't already know. First step to identify we're dealing with trig, or are we dealing with Pythag? Sam, are we dealing with trig or Pythag here? For question 1C. Trig, how do you know it's trig?
Because it gives us an angle.
It gives us an angle. So that's my first step. I've identified that I'm dealing with trig. Number 2, I need to label my side. So what side don't I care about?
H.
I don't care about my H. So that's probably an indication about which identity I'm using. Or which side do I know? The 16, that's O. And which side's my X?
A.
So if the trig identity has H in it, it's no good to me. Which one doesn't have H in it? Yeah, tan, Toa. So I could write Toa if I want, or I could write tan theta equals opposite over adjacent. Now I always write the formula for 2 reasons. Number 1, it stops me making errors. And number 2, it gives me marks in that second criteria for showing working. Clear? So make sure we always show our equation. That's the same for all 3 of these. So that'd probably be the only critique I have of that response is that it needs an equation. Everything else is all good. Once I've got that, what do I need to do, Adam?
You need to tan over the angle.
Okay, before that, you're right, but before that, what do I need to do?
You need to find out what.
Well, what's in this equation here?
O over A.
Yep, and theta. Do I want those or do I want something else? What should I put in place of theta? What's theta?
35.
So I should replace theta with tan in brackets 35, original bracket theta, equals 16 over
A.
x or a is fine. It is fine. So now what's different about this example?
X
X on the bottom, we don't want X on the bottom, we need to get it to the top. Now we can't just move things. There are a couple of ways I can show you this, but I'm going to teach you a way that works all the time. It's probably not the most efficient way, but it's going to work all the time. Because we can use reverse bombast and opposite operations for rearranging, correct? And that's what we're doing here. We don't need a special shortcut, we just need to apply that principle effectively. So I've got divide x, and that's a real problem, so I need to get rid of that problem. How do I undo a divide x? Times x, and provided I do it to both sides, I'm all good, aren't I?
Yes.
What happens to the x's on the right? They cancel out, so my new equation now is x times tan 35. Yeah, tan 35 is a number, we just write it as tan 35. So it's just some number. So if I've got x times some number, how do I get rid of that number?
Divide.
I divide both sides. So I'm just going to divide this side by tan 35. And I have to do it to the same to the other side. What happens to the tan 35s? They cancel out on the left hand side. I'm left with x equals 16 divided by tan 35. And then I'll pull my calculator and I'll show that in. I get x equals
22.85.
22.85. I'm just going to make it 9. We'll do 22.9 centimetres. Cool. If you got that, well done. Like that's just challenging a baseline, without going to real problem solving tricky stuff. That's as challenging a familiar question as I can ask you. Because there's a fair bit of rearranging in that. You need to get your variable from the bottom onto the top. So that's, if you got that, very, very well done. That's a really good tick. If you got to these problems and you got these, like that's where I was sort of hoping we'd all be at. If you're not there, that's fine. We can work on that, but that's where we should be at. If you're getting this, you're really proficient. You're doing the right thing. So what we're going to look at now is a situation where instead of, if I gave you this triangle here, I'm just going to replace some values. If I gave you the triangle for A, I'm I'm going to give us a technique for finding x. So I want you to think about, before we go any further, what do you think we need to do? I'll give you a minute to think about that and maybe discuss it with the person next to you. Think about what we need to do to try and solve that, because that's just an unknown. So let's see if we can get anyone to figure a solution out.